Hello Stings. In this video we will be looking at the process called cannot for simplifying radicals. In our first example we will be looking at the square root of 8. So here's example 1. Because 8 is not a perfect square, and if you're not sure whether the number under the radical is a perfect square or not, then what you need to do is look at your resource section, go to your perfect squares list and see if it's in that list. If it's not, then we need to do this process. So what we do first is we look at the factor pairs for 8. We have 1 times 8 and 2 times 4. We are looking to see if one of those factor pairs has a perfect square as its factor. And we in particular need the largest perfect square. So in this case 4 is the largest perfect square factor of 8. So we are going to split this up into can and cannot. 4 is a perfect square, so I can take the square root of 4. I, however, cannot take the square root of 2. There is no whole number that I can multiply by itself to get 2. 2 is not a perfect square, so we cannot take the square root of it. Then we take and simplify each of those. The square root of 4 simplifies to be the whole number 2. The square root of 2 is as simple as it gets, so we get 2 times the square root of 2, and that is the simplification for the square root of 8. Here are the rest of the notes. We did the same thing with 20. We looked at the factor pairs for 20. We have 2 times 10 and 4 times 5. 4 is the largest perfect square factor of 20. So we can take the square root of 4. We cannot take the square root of 5. We simplify the square root of 4 to be the whole number 2. The square root of 5 is written down next to it. This is multiplication. 2 times the square root of 5 is the simplification for the square root of 20. For example 3, we have the square root of 48. Factor pairs are 2 times 24, 3 times 16, 4 times 12, and 6 times 8. There are 2 perfect square factors, 4 and 16, the largest being 16. So we will use the factor pair 3 times 16 in our cannot process. We can take the square root of 16. We cannot take the square root of 3. The square root of 16 is 4 because 4 times 4 is 16. The square root of 3 cannot be simplified anymore, so it just simply gets written down. So the square root of 48 becomes 4 times the square root of 3. In the fourth example, we have the square root of 50. We have 2 times 25 is 50 and 5 times 10 is 50. 25 is the largest perfect square factor of 50, so we will use 2 times 25 in our cannot process. We can take the square root of 25. We cannot take the square root of 2. The square root of 25 is 5. Square root of 2 simply gets written down. 5 times the square root of 2 is the simplification for the square root of 50. In example 5, we have a much longer list of squares, of perfect squares that are factors. So here we have 2 times 36, 3 times 24, 4 times 18, 6 times 12, 8 times 9. All of these are factor pairs for 72. We are going to leave the 3 alone for now and focus just on the square root of 72. We see that 36, 4, and 9 are perfect square factors. We want the largest perfect square factor, so we're going to use the 36. So we have 2 times 36 as the factor pair that we will use to simplify the square root of 72. We can take the square root of 36. We cannot take the square root of 2. The square root of 36 becomes 6. The square root of 2 stays the square root of 2. Now this is just the square root of 72 part. So what we will do now is go back to the original problem. We will substitute in this simplification in for the square root of 72. Now we see 3 times 6 times the square root of 2. We can take the 2 whole numbers, 3 and 6. We can multiply those together to get 18. And so in simplified form, 3 times the square root of 72 becomes 18 times the square root of 2. So we need to remember to look at our factor pairs, find the largest perfect square factor of the number under the radical sign, use that in our cannot process, simplify. Those are the steps for simplifying radicals using the cannot process.